The last situation we'll deal with is graphing real-world function rules. So this is basically, if I give you a real-world scenario, a real situation, how is that going to be any different than what we've just done? And the answer is really not that much different. There are a couple of slight things that you have to be aware of. First, we read the problem. It says that the function rule C equals 5 plus 2D represents the late charge on a cell phone bill. In the function rule, C is the total charge and D is the number of days that it's late. We're going to show a graph that represents our function rule. We're going to be asked to input our independent and our dependent variables. The nice thing is, your X variable is always your independent and your Y is always your dependent. Well, the way that we are working these, your X is always this column on the left. So that's always how you would label your independent variable, in this case, number of days. Your Y is always what you're calculating, so it depends on your input value, or your X. So in this case, it's cost. The major difference here is that all those rules I told you about, function rules and fractions and what letters to choose, kind of get thrown out the window when it's a real-world situation. Because if I look at the function rule I have set up to do my process, we don't see a fraction. We think we're going to pick positive 2, negative 2, positive 1, negative 1, and 0. The problem is, in this situation, negatives don't make sense. The reason negatives don't make sense here is because they're talking about the number of days a bill is late. And it can't be negative 1 day late. That would be on time. It's not late at all. So here, we just start with 0. We want to always check 0, but this real-world situation, we're going to check 0, 1, 2, 3, and 4. So the major difference here, if it's a real-world situation, you have to ask yourself if it makes sense to check negative values. If not, check 0, 1, 2, 3, and 4. If you're not given this in a real-world situation, then you check your positive 1, negative 1, positive 2, negative 2, and 0. I want you to go ahead, press pause, fill the rest of this table in. When you're done, unpause, and we'll talk about how to create our graph. So double check your work, make sure that you got the same answers as me, make sure that those answers make sense. If you did not get those answers, check your arithmetic again, and then come back to this spot. When creating our graph, there's 3 things that we have to do. First, you have to give it a title. You want that title to be somewhat specific to the situation. There's no one correct answer, but you want it to be something that has to do with the situation that you're dealing with. In this case, we're dealing with the late charge on a cell phone bill, so we might title this late charge. Second thing you need to do is label your y-axis and your x-axis. Your y-axis is always your dependent variable. In this case, it's cost. Your x-axis is always your independent variable. In this case, it's days. And the third thing that you need to do is put the numbers or the scale on your axes. If it is a real-world situation, we will typically give the graph to you in this format, where this point down here will always be the origin, or 0, 0, and you work from there. Here, your x, you just need 0, 1, 2, 3, and 4. So we can just number them that way. You can go all the way or you can stop at 4. It doesn't matter to me. In your vertical axis, you need to make sure you get as many of these ordered pairs or points as you can. So I know I have to get at least up to 13. So if I counted by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, that's enough. You don't have to label every single point, but every single point has to be worth the same amount. What I mean by that is, sure, this is 1, 2, 3, 4, and so on. But if you want, you can label just the even ones. It doesn't mean that these aren't 1 and 3. It just kind of makes it look a little bit neater. So that's 5, I just don't have to write it. That's 6. 7, I don't have to write it. That's 8. Don't write 9. 10, there's 12, and there's 14. So all of them are worth the same amount. I just happen to be writing just the even numbers. Now I have enough where I can go and plot my points. 0, 5, 1, 7, 2, 9, 3, 11, and 4, 13. I have all of my points. I'm going to draw my line. This is the one case where, since we're not checking negatives, I don't want an arrow on both ends, just on this end. Because if I go back that way, I'm talking about my negative x's. Okay, your homework is listed in iTunes U. Make sure you get your homework done for the evening. It'll be passed out to you by the sub, and it will be collected tomorrow.